in the dissociated form. Now we take up next question, students. Arrange the products obtained in the following cases in increasing order of their reactivity towards SN1 mechanism. So first we will find out the products. So this you have to solve these questions very seriously, students, very carefully. Methyl propene, when reacts with HCl, so we get this product, students. Tertiary butyl chloride. And reaction of benzyl alcohol with PCl5, we get this benzyl chloride. And reaction of tertiary butyl alcohol with HBr, we get this, student, tertiary butyl bromide. So these are the products obtained. Now we have to arrange these products in increasing order of their reactivity towards SN1 mechanism. Now, increasing order of reactivity. So this is the demand of the question. You have to just arrange these in increasing order of their reactivity. So this is the right answer, students. First is B. B is this benzyl chloride, then A, and then C. This is most reactive and this is least reactive. And A is of intermediate reactivity. Now the reasons have not been asked. Now let us discuss the regions. Now rate in SN1 reaction is determined by how the rate in SN1 reaction is determined. Stability of carbocation intermediate. More stable the carbocation, more fast will be the reaction. And the leaving group's ability. Bromide is leaving group's ability. More is the better is the leaving group. More easily it can leave, more faster will be the reaction. So bromide is better leaving group than chloride ions, because here we are involving chloride and bromide here. Two leaving groups are there only. Now determining the order of the reactivity order. The carbocation involved, यहाँ जो कार्बोकेटाइन इन्वॉल्व हुए हैं वो है टर्शियरी ब्यूटाइल कार्बोकेटाइन, this is, and the benzyl carbocation. This is from here we will get tertiary butyl carbocation. From here also these two will give tertiary butyl carbocation, and this will give benzyl carbocation. Now tertiary butyl carbocation and benzyl carbocation are involved, and this tertiary butyl carbocation is more stable than benzyl carbocation. This is more stable than this carbocation. Now comparing A and C, both produce same carbocation. A and C, same carbocation is produced from this. Both produce tertiary butyl carbocation. But bromide is better leaving group than chloride. Bromide is better leaving group, so carbocation from this will be formed more easily, more quickly as compared to that formed in this case. Therefore, this C is more reactive than A. So this one part we have found out. This is more reactive than A part. Next, comparing A and B. Both have the same leaving group. But tertiary butyl carbocation, the carbocation obtained from this is slightly more stable than the carbocation obtained from this. From here we will get tertiary butyl carbocation, which is more stable than the benzyl carbocation. Therefore, A is more reactive than B. So what we have found, students? C is more reactive than A, and A is more reactive than B. So this is the reactivity sequence in increasing order. Next question, students. This is a 4-mark question and it is data based question. This is the paragraph. So some teachers speak that you need not to read this paragraph, you simply answer the questions, but it is up to you. It depends all on you. You can answer without reading this paragraph, but if you need, you should read it. So these are the questions, students. What is the basic structural difference between starch and cellulose? And what is the hydrolysis product of lactose? So the basic structural difference between starch and cellulose. Starch is a polymer of alpha D glucose, and It has two components, amylose and amylopectin. This is part of syllabus. Very important. Amylose is a long unbranched chain polymer of alpha D glucose units which are held together by C1 C4 glycosidic linkage. Amylopectin is branched chain polymer of alpha D glucose units. They are also held together by C1 C4 glucosidic linkages, whereas branching occurs at C1 and C6 glycosidic linkage. All this you have to tell in structural difference because you are talking about structure. And cellulose is a straight chain polymer of beta D glucose. This is the main difference, that here is we have alpha D glucose, here we have beta D glucose, and which are held together by C1 C4 glycosidic linkage, which is same as in starch. But you have to write down. Next is hydrolysis of lactose. So hydrolysis product of lactose is, this is lactose. Sucrose or lactose both have the same molecular formula. It is a disaccharide, and we get 2 units of the monomers, 2 units of the monosaccharides, D plus glucose and D galactose. So lactose on hydrolysis give one molecule of glucose and one molecule of galactose. You cut this from here. Now next question is, what is the hydrolysis product of maltose? So this is maltose. Maltose also have the same formula, C12H22O11. This is also a disaccharide, and here we get both units as D glucose. Both are alpha D glucose. So this so maltose on hydrolysis gives 2 molecules of D glucose. Now next is draw the structure of sucrose. Why is it called invert sugar? This is also very important question, students. Now the structure of glucose is this. This is given in an NCERT book. This is glucose unit and fructose unit. Sucrose is also a disaccharide, and it contains 1 unit of alpha D glucose and another is fructose units. So this structure is given in NCERT book, so you can also write this structure or this structure. Both are same and both are correct, and you have to write any one of these. Now sucrose is a dextrorotatory substance, means positive, rotation is positive. Hydrolysis value need not to be memorized by students because during the examination it is likely to be forgotten. So it is dextrorotatory. Hydrolysis of sucrose gives equimolar mixture of D plus glucose and D minus fructose. This is important point. We have glucose unit and fructose units. This equimolar mixture is called invert sugar. Why hydrolysis of sucrose bring about, because why is it called invert sugar? Because hydrolysis of sucrose brings about a change in the sign of rotation from dextro to levo, from plus to minus sign. Therefore this is called invert sugar. जो सब्सटेंस हमें मिलते हैं वो इन्वर्ट शुगर होता है, बिकॉज साइन ऑफ रोटेशन हैज़ बीन चेंज्ड फ्रॉम द इनिशियल साइन. नेक्स्ट क्वेश्चन स्टूडेंट्स, oxidation state in transition elements. You see, this is also a paragraph based question. Name the transition element of first transition series which does not exhibit variable oxidation state. The answer to this is scandium. Scandium, its symbol is Sc. You write symbol or the word scandium. It does not show variable oxidation state. Or you can write which transition elements show only +3 oxidation state in the first transition series. Answer to this is also scandium. Scandium. It shows only +3 oxidation state and no variable oxidation states. Now explain why Cu plus ion is not stable in aqueous solution. This is also very important question. Now Cu2 plus aqueous is more stable than Cu plus aqueous. Second ionization enthalpy of copper is large, but hydration enthalpy for Cu2 plus is much more negative than that for Cu plus, Cu1 plus, and hence it is more then compensate for the second ionization enthalpy of Cu. What happens here, students, that when this 1 plus is converting into 2 plus, ionization enthalpy is to be supplied to the species. But when it becomes 2 plus, the hydration enthalpy is more than that of this. So increase in hydration enthalpy is more than compensates for the second ionization enthalpy of copper. Therefore, Cu plus ion is unstable in aqueous solution and it undergoes disproportionation according to this reaction. 2 Cu1 plus gives Cu2 plus Cu copper solid. Now next part is explain why manganese exhibit highest oxidation state of +7. Also write a compound of manganese in +7 oxidation state. So the answer is electronic configuration of manganese, student. It is 3d5 and 4s2. The configuration, the atomic number is 25 for L manganese. The 3d and 4s levels are close in energy. 3d and 4s levels are close in energy. All the 7 electrons, 5 from 3d and 2 from the 4s, are used for bond formation. Hence, manganese exhibit highest oxidation state of +7. The compounds in +7 oxidation states are Mn2O7 and KMnO4. KMnO4 is very important. You should memorize this. Its oxidation state is +7. This is in your practical exams also for titrations. Next question, students. Write the products formed when ethanol reacts with the following reagents. So ethanol is acetaldehyde, students. So these are all reactions of ethanol, acetaldehyde. Let us see. This is ethanol and this is semicarbazide. When it reacts with semicarbazide, in presence of acid, we get water. Water is found from here and we get this compound, ethanol semicarbazone. From semicarbazide we get semicarbazones. Next is with dilute sodium hydroxide. So the reaction actually is, student, ethanol undergoes this type of reaction in presence of dilute NaOH. You may find out from, you have to write this reaction. The carbonyl group of one molecule interacts with the alpha hydrogen of another molecule. So this is an aldol reaction. So here first this product is formed. It is called aldol because aldehyde and alcohol groups are there. Aldol and OL is there. Now when this is heated, it undergoes this reaction. Now in the question, what we are given reaction with this. Heat is not written here. So you have to write these reactions as separate ones. Write this compound again and write this. Most probably, according to me, only this part is to be given as answer to this question. But if you have time, write down this also. This is aldol condensation product. And next part is zinc amalgam and HCl. When acetaldehyde or this ethanol is treated with this reagent, we get this reduction of the aldehyde group takes place. This is Clemenson reduction. This part is Clemenson reduction and we get ethane. Next is, students, distinguish between this pentane 3-on and pentane 2-on. Now here pentane 3-on and pentane 2-on. Pentane 2-on, when treated with sodium NaOI, sodium hypoiodide. This is used for iodoform reaction. A yellow precipitate of iodoform is formed because it is a methyl ketone, while pentane 3-on will produce no yellow precipitate. So this way we can distinguish. Now next is acetic acid and ethanol. Ethanol reduces tolerance reagent. This is tolerance reagent, ethanol. It is an aldehyde, so it will reduce tolerance reagent, producing silver mirror. But acetic acid will not reduce tolerance reagent. And you have to write the reactions in this way. Even if you don't write this line, then also these reactions will speak what you have said here. So you have to write only one distinguishing test. Here another I have given, ethanol reduces Fehling solution also to a red precipitate of Cu2O. This is red, this is because of ethanol, it is an aldehyde group. So now acetic acid does not produce the red precipitate of Cu2O, cuprous oxide. So this way also they can be distinguished. There is another test, students. This is sodium hydrogen carbonate test. Acetic acid, being an acid, it decomposes the sodium hydrogen carbonate, producing brisk effervescence of carbon dioxide. Now, ethanol, when treated with sodium hydrogen carbonate solution, no effervescence, no evolution of CO2 gas takes place. It doesn't react with this. This is also a distinguishing test. You can write any one of these. All are correct. Now, next, student. There is choice in this question. An alkene A molecular formula, this on ozonolysis gives a mixture of two compounds B and C. Compound B gives a positive Fehling test and also reacts with I2 and NaOH form iodoform. Compound C does not give Fehling test but form. You write down this the main points of this question and try to find the answer yourself. I am giving you the answer. Pause the video and solve yourself if you can. Now students, analyzing this question, we get that this is a 5 carbon alkene, and on ozonolysis, this is ozonolysis, it gives a mixture of two compounds B and C. So B is giving a positive Fehling test and also reacts with this to form iodoform is also formed. So B must be an aldehyde. And C does not give Fehling test, so this is not an aldehyde, might be a ketone, because aldehyde or ketones are formed on ozonolysis. So and that is both are forming iodoform, both gives iodoform test. So both must have the methyl ketone group as part of the molecule. So based on this information, we get that this A is this alkene. It is 2-methyl-but2-ene, and on ozonolysis this bond is broken down, and so we get ethanol and this acetone, these two compounds. So this is B and this is C. Now B, why is it B? Because it gives Fehling test. It doesn't give, because it is a ketone, so it doesn't give Fehling test, and both will give iodoform test. So you have to write down the structures like this and write down the reactions in this way. This is ozonolysis, B and C. This is A. Once you have written the names, no need to write it again and again. This is ethanol and Fehling test. This is red precipitate of cuprous oxide, and again this is from iodoform test, and we get yellow precipitate of iodoform. Next, student, reactions of C, that is acetone with for iodoform test, we get here iodoform, yellow precipitate, and when acetone is treated with Fehling solution, no red precipitate, because ketones don't give this test. Next, we have to write the reactions of ethanol with 2,4-DNP, 2,4-dinitrophenylhydrazine, and methanol in presence of dilute NaOH along with heating. Here dilute NaOH along with heating is written, so we have to write the complete reaction. So students, here is the reaction of ethanol with 2,4-DNP. This is ethanol and this is 2,4-dinitrophenylhydrazine. So what we get here, elimination of water takes place from here to here, two hydrogen atoms and one oxygen atom. Water is eliminated and we get this product with a double bond with this carbonyl carbon and nitrogen. This ethanol 2,4-dinitrophenylhydrazone is formed. Now methanol in presence of dilute NaOH along with heating. So these two molecules of methanol reacts with dilute NaOH, and this is what is this? No, this is what methanol with it. This is a reaction of ethanol. Sorry, ethanol with methanol. So one molecule of ethanol and methanol. This has alpha hydrogen, this doesn't have alpha hydrogen. So we get this product. This is cross aldol product. Carbonyl carbon of methanol is involved with alpha hydrogen of ethanol. So we get this product. Now another product will be a self aldol product. This is formed from two molecules of ethanol, because ethanol is being present here under the same situation, so self aldol products will also be formed. So in this reaction only two products will be formed, because this doesn't have alpha hydrogens, so only two products. Next question, students. Metal ion Mn plus of first transition series having D6 configuration combines with three didentate ligands, and assuming octahedral splitting is less than pairing energy. So we have to draw the crystal field energy level diagram for 3D orbitals of this level of this complex. This is shown here, students. Crystal field energy level diagram, 3D orbitals. How these are the 3D orbitals, D6 configuration. So you have to write down the 6 electrons here, and the energy of the levels of these orbitals lifted in the symmetrical spherical crystal field. Now when it is in the octahedral field, we get this splitting. These are Eg orbitals and these are T2g orbitals. Since this is less than the pairing energy as is given in the question, so all the 6 electrons are filled in this way. First, second, third and fourth electron migrates to this because it is less than the pairing energy. Then fifth electron, then sixth electron comes here. So this diagram you have to show up here. Next question is, name the type of isomerism exhibited by this complex. This complex will show an optical isomerism because it is 3 didentate ligands. So the structure is not to be drawn as a part of answer, but the structure would be like this. This is didentate ligand, one here, one here. These are 4 bonds. This 1, 2, 3, 4 octahedral complex. These are in one plane, and this is above and this is below the plane. So this and this. So this shows optical isomerism. So the isomerism is optical. And next question is, what is the hybridization of Mn plus in the complex? Complex, what is the hybridization? It is sp3d2. It is outer orbital complex since this is less than the pairing energy. Because this is less than pairing energy, so here splitting is less. If splitting has been more because of the strong field ligand, then it would have been higher and pairing would have occurred here. This would have been vacant and it would have been used for the hybridization. So this is not used. So this is outer orbital complex and it is sp3d2, not d2sp3. So this is the hybridization. Next question is, what is the magnetic behavior of Mn plus in this complex? Magnetic behavior is, here we see that the number of unpaired electrons is 4. So we will calculate the magnetic moment as shown here, mu this n into n plus 2 square root. So we get 4.90 Bohr magneton. And coordination number of this is 6, 3 didentate ligands. Now this question has a choice. The complex having this formula. Complex having this formula CrCl3.3NH3.3H2 reacts with AgNO3, forming 3 moles of AgCl. Now 1 unit of this gives 1 mole of this gives 3 moles of AgCl. Conducting studies shows it is a 1:3 electrolyte. Now identify the complex and write its structure. So the answer to this part is The reaction of complex with AgNO3 indicates that all the three chloride atoms are present as ionizable chlorides. Therefore, they are outside the coordination sphere. So this gives 3 more. So we get the 3 chloride ions here. They were outside this. So the nitrates will also be outside this in the product, outside the coordination sphere. Next, conducting studies shows the complex is 1:3 electrolyte. Therefore, it confirms the structure Mn3 plus because 3 chloride ions are here. So it is 3 plus ion and this is 3 chloride minus. So this is the structure of the complex. And this we get this. These are total of 4 ions are there. So the complex is now the we have to identify the complex and its structure. So this is the complex. This 3 water molecules, 3 ammonia molecules, and this 3 chloride ions outside the coordination sphere. IUPAC name is triamine and triaqua chromium third. Oxidation state of chromium is +3 chloride. Now oxidation number of chromium is +3. Coordination number is 3 + 3 6. And next is what? Can this complex show geometrical isomerism? If yes, draw the geometrical isomers. Yes, the complex shows geometrical isomerism. FAC and meridol. Yeah. Now, these 3 ammonia, these 3 ligands form one phase, and these 3 forms another phase. So this is FAC isomer, and this is MER isomer. This is on one meridian, this 3 NH3s, 1, 2, and 3. Another on another meridian. Now next question, students. At 298 Kelvin, delta G naught of the following cell reaction is this one, kilojoule. It is kilojoule per mole. This is the reaction. Calculate the log Kc for the given cell reaction. Now delta G naught is this, which is equal to 210,300 joule per mole, and temperature is 298 Kelvin. Our gas constant is 8.31. Now the formula we are going to use is delta G naught is minus RT natural log Kc, and this is equal to minus 2.303 RT log to the, this is to the base 10, which has been asked here. Now substituting the values and solving them, we get this is the value of log Kc. Now next part is conductivity of this much molar methanoic acid is 8 into 10 to the power minus 5 Siemens per centimeter. Calculate its molar conductivity and degree of dissociation. If lambda naught m means limiting molar conductivity of methanoic acid is 404 Siemens centimeter square per mole. Now concentration of the solution is this, is so much mole per liter. This comes out to be this. Now conductivity kappa is this much. Now molar conductivity is related with kappa and C in this form. So molar conductivity will be equal to this much, 4 into 10 to the power, it comes out, substituting the values we get 4 into 10 to the power minus 2 Siemens per centimeter square per mole. Now for methanoic acid, lambda naught m is given. Now degree of dissociation is alpha equal to lambda m by lambda naught m. And substituting these values, which has been calculated here and here, we get it is 9.9 into 10 to the power minus 5. Now this is last question, and it has a choice also, students. Now represent the cell in which the following reaction takes place. This is the cell reaction, students. So first we have to represent this. Now take care, here question 1 is asked. Generally students forget this, they just solve these parts. To take care that here is also a question, and its marks are duly given. If you don't attempt this, marks will be deducted. So this is the cell reaction, students, as given in the question. This nickel 2 plus 2Ag gives nickel 2 plus 2Ag, and concentrations are also given. here cell representation is this one. Here oxidation taking place, so this is anode, and this is reduction taking place, so this is cathode. Silver is cathode and this nickel is anode. So so cell representation is nickel oblique this nickel diplus. This is the cell representation. You write it along with the given concentrations. Now for the next question, E cell at this, we have to calculate this E naught cell. E naught cell is also given to us with this value of E naught silver. No, E naught cell is not given. E naught cell we have to calculate. This is for nickel and this is for silver electrode. Electrode potentials are given. Log 2 value is also given. Let us find the value of E naught cell. This is cathode minus anode. So we will substitute and we get it is plus 1.05 volt. Now for E cell equal to E naught cell minus this formula, and we substitute these values. Take care. The concentration of silver ion is raised to power 2 because of this 2 in the cell reaction. It is in the cell reaction. It is 2. So we calculate this, and by substituting these values, we get 4 into this part, and we substitute this. Log 2 is involved here, and subtracting this we get 0.914 volt. Do the calculations yourself. Now next, calculate the work done by the cell at the given concentration. Now work done by the cell is given by this formula minus delta G, which is equal to NFE cell. If it is standard, then E naught cell we will take. Now here this formula. So N is 2 because 2 electrons are involved in the cell reaction. Faraday, value of Faraday, 1 Faraday, and then E naught cell, E cell is 0.914. So we calculate this, we comes out to be 176.59 kilojoule. This is the work done by the cell. And next, students, define molar conductivity and 1 Faraday. These are also very important questions. You see molar conductivity, it is denoted by lambda m. Molar conductivity of an electrolytic solution is defined as the conducting power of all the ions produced by dissolving 1 mole of the electrolyte in the solution. जो 1 मोल इलेक्ट्रोलाइट से जितने भी आयंस प्रोड्यूस होते हैं उसमें, वो उसकी मोलर कंडक्टिविटी होती है, एंड इट इज़ इक्वल टू कप्पा बाई सी, वेयर दिस इज कंडक्टिविटी एंड सी इज मोलर कंसंट्रेशन. नाउ 1 Faraday is defined as the total charge carried by 1 mole of electrons. So 1 Faraday approximately is equal to 96,500 coulomb per mole and charge is equal to equal to Q equal to current into time, N into F, where N is the number of moles of electrons. So with this, the question paper comes to an end, and students prepare well, and I wish you all good marks. Best of luck for your exams.